Have you ever dropped your phone and, in that split second before it hits the ground, had your life flash before your eyes as you wonder, why? Why must you fall? It seems like such a simple question, right? Things just fall. But the story behind that why is one of the most epic tales in the history of science. For centuries, the greatest minds on the planet have puzzled over this exact question, and their journey led us to one of the fundamental forces that shapes our entire universe: gravity. It all started with an apple. Well, at least that's how the story goes. Sir Isaac Newton was supposedly chilling under a tree when an apple bonked him on the head, or fell nearby. Historians are fuzzy on the details. But it sparked a world-changing thought. Why did the apple fall straight down? Why not sideways or even fly up into the sky? This simple observation led him to a revolutionary idea. Every single object in the universe with mass pulls on every other object. That's right, you right now are technically pulling on the moon, and the moon is pulling right back on you. The more massive an object is, the stronger its gravitational pull. The Earth is, incredibly massive, so its pull is strong enough to keep everything from apples to you and me firmly on the ground. This is Newton's law of universal gravitation, and it was a game changer. For over 200 years, Newton's theory was the final word. It worked perfectly for predicting the motion of planets and calculating the paths of cannonballs. It was the undisputed champion of physics. But then, another genius stepped into the ring. A guy named Albert Einstein. He looked at Newton's idea of a mysterious pull and wasn't totally satisfied. He asked a brilliant question. How does the sun, across millions of miles of empty space, actually tell the Earth to orbit it? Is it sending a text? A cosmic carrier pigeon? Einstein's answer was completely mind-bending. He proposed that gravity isn't a force at all. Instead, it's a consequence of how mass literally warps and curves the very fabric of the universe, something he called space-time. Picture this. Imagine space-time is a giant, stretchy trampoline. Now, let's place a heavy bowling ball, representing our sun, right in the middle. You can see how it creates a deep curve, a dip in the fabric, right? Now, if you roll a smaller marble, let's say representing the Earth, nearby, what happens? It doesn't get magically pulled by the bowling ball. Instead, it starts to follow the curve in the trampoline, rolling around and around the bowling ball in an orbit. That, in a nutshell, is Einstein's theory of general relativity. Mass tells space-time how to curve, and that curvature in space-time tells other objects how to move. So, when you drop your phone, it's not actually being pulled down by some invisible force. It's simply following the straightest possible path through the curved space-time created by the Earth's immense mass. What we experience as the force of gravity is really just us moving along these cosmic contours. This might sound like something out of a sci-fi movie, but it has been proven to be true over and over again. It explains things Newton's theory couldn't, like a tiny wobble in Mercury's orbit and the way starlight actually bends as it passes by massive objects like our sun. And it's not just some abstract cosmic theory. It's incredibly practical. The GPS in your phone that tells you how to get to that new coffee shop? It relies on constant corrections based on general relativity. Gravity actually affects the flow of time. It runs slightly slower closer to a massive object. Without Einstein's understanding of this, your GPS would be off by several miles every single day. So, the next time you drop something, take a moment to appreciate the incredible journey of scientific discovery it represents. From a simple falling apple to the very fabric of the universe being bent and curved, the question, why do things fall, reveals a cosmos that is far more strange, elegant, and interconnected than we ever could have imagined. It's a constant reminder that even the most ordinary, everyday events are governed by extraordinary cosmic laws. Thanks for joining me on this journey through space and time. If you found this as fascinating as I do, Do me a huge favor and hit that like button, and be sure to subscribe for more deep dives into the wonders of our universe. See you in the next one.